We are live right now.
Oh,
Hey,
we're live. Look at
we
that.
are over here. Thank you very much. Let me introduce yourself a little bit, all right? This company decided to tackle the number one enemy for consumer tech, like phones, tablets, laptops, etc., which is heat. With their amazing radiative cooling technology, they're helping keep your devices healthy for a longer time. Let me introduce Cryo X. Hello everyone, welcome to another episode of Builder Nation. I'm your host Sam, and today we are joined by Jordan Fourcher, CEO at Cryo X. Welcome Jordan, thank you very much for joining us today. This is not your first appearance actually, Builder Nation, as you left a comment back on one of our previous live streams. It's great to have you here. Thank you very much for joining us. Could you please introduce yourself a little bit?
Yeah, sure. I'm Jordan Fourcher. I left that comment on your guys' Hextronics interview because Hextronics is one of my clients. I love those guys. Met them down in Miami when I was just starting out, and they've watched me go all the way from prototype to delivering to them. So it's been a really cool journey with them. So I had to show up and support them. I am Arizona over here. I live in Arizona. It's hot out here, so of course I had to do something about it. So I'm making a self-cooling vinyl to deal with that. So I know you mentioned in the preamble that there's electronics and things like that, basic like mobile electronics, consumer electronics that have issues. But nowadays at CryoX, we're doing things a little larger. So we're kind of moving up the scale here. This is a piece I cut out
Right.
some. It's a vinyl. You can cut it to whatever shape you want. You can put it on things like IoT boxes. Like let's say you have to make a little IoT box, of Internet of Things box, and it has to sit outside, and you have to deal with thermals, and you don't want your batteries to explode. This is your solution. Let's say you have a car, an ambulance. We are actually deployed to an ambulance right now. You want your paramedic to be not heat fatigued, right? I would. So put some on the roof, cool it down. So that's just a little bit about what we're working on.
And it's honestly a really amazing tech. Like I can vouch for this. I have been really delving deep into your vinyl, into the cryo skin is I believe the appropriate name for this.
Yes.
It's honestly amazing. So first of all, I wanted to begin just a few steps back. All right, a little more into the basics of this. And the first question that I wanted to ask you is actually, how did you come up with this idea? I know that you started this on college. I believe it was as a project, if I'm not mistaken, and sort of the company sort of scaled up from there. But my first question is: you already mentioned you live in Arizona. It's a very hot place. You don't want your paramedic to be in a heat streak. So we don't want any of that. But how did the idea of this cooling tech, and more importantly of the cryoskin, come to happen?
It's a long story, but I'll make it short. So when I was at ASU, I've always been wanting to do my own business, right? That's just how I am. And I was trying to think about things that I could fix, right? Things where I could apply my skills, my knowledge to go fix. And I have a little bit of a tinkering background. Now, if I say I'm an engineer, my old roommates who were officially engineers would laugh at me. But I was the guy with the 3D printer, right? So I originally went into mobile consumer electronics because that's what I was totally into. That's like my thing. I love phones. I love smartphones. I love tablets, computers right now. So I got like 2 iPhones in my room doing shit right now. It's like crazy.
That's nice.
Um, but the problem is that they overheat, right? And that when they charge, they overheat and that damages the battery. So my first thing I made was a wireless charger that actively cools your phone. It was about this big, yay big, and it had a full water cooling system, thermoelectric plate, you name it. It was fancy and very effective. It could freeze a phone.
Sounds it was
Uh,
overkill a little
it
bit.
was overkill, yes, but I decided to shelve it because I finished it around early 2021. And I don't know if you remember, but the supply chain was not looking so healthy then, and still to this day is not fully recovered. And it had quite literally too many moving parts for me to trust that the supply chain to not lose one of the parts. Because if you don't have one
Right.
of the parts, the thing doesn't work, right? So it's like, okay, I was going to shelve it until I had more patience for the supply chain. In the meantime, I was working on a little back project, a little radiated cooling back project. I gotten some samples from another company of this paint they had made, and I was applying it to different surfaces. And of course,
Hmm.
it didn't want to work with any of the surfaces except for one, which was the vinyl. So
All
there's only
right.
one surface it would work on. It was the vinyl. Everything else it would have issues with. So I ran with it. I was like, okay, well, what else do you put vinyls on? And because I came from the world of cell phones, I know that you can do phone skins, right? D brand is a big one who's a
Yes,
sponsor
big
of
name.
tech channels. Yeah, MKBHD likes to name drop D brand all the time. So I was very familiar with phone skins. It's like, okay, so I sent it a phone skin. The company painted it with their paint, sent it back. That was my first prototype. Right then and there, that was my first prototype. Put that on a Samsung phone that could measure its internal battery temperature. Got it an identical phone. Set them both outside in the middle of the day, and lo and behold, 15 degrees of temperature difference. And I was like, that's it. I spent the next year R&Ding it to make it actually consumer friendly. Because yes, it worked, but it was very fragile, not easy to use. If you bent it even a little bit, it'll crack off, the paint would crack off, not easy to use. Yeah. So I did a year, pretty much a full year, over a year of R&D, and now it's this smooth, I don't know if you guys can see super well, but this very smooth, very flexible vinyl that's self-adhering, which means that it's easy to use. I mean, like, what's the point of a product if it's difficult to use, right? So I made it very easy.
Agree. I agree with that. In fact, I mean, I definitely have already heard of skins. I didn't really know that the the use case for them could be so, I mean, so advanced. Now, I'm very curious about how you mentioned you built your first it was a wireless charger that was about yay big, as you mentioned.
Yeah.
It was not that big, and it was a little bit overkill, right? But I mean, I completely understand that you wanted to make sure it actually cooled your device. Now, how did you first get into the world of this radiative cooling tech? Because in the end, it is not common science. If I have to say something, it's not really a common science in the materials space, at least in material sciences, not very common. So how did you first dive into that? What kind of study do you have to do? How many iterations did you have to do until you actually fell into the the vinyl that you just showed us that is very flexible and can be cut and can be DIY'd? How did you do it?
Well, part of my success and my drive to keep going in this entire industry stems from the fact that it's very, very difficult to go anywhere in it. My company, Cryo X, holds the title of being the first and only consumer-facing radiative cooling company.
Right.
Meaning that I got a buy button on my website. You go to anyone else making radiative cooling, and it's a hassle to even get a sample from them,
Right.
let alone buy it. Very difficult. Part of it's because their products are typically harder to use. They're not. I designed mine from the ground up to be super easy for consumers, all the way up to technicians to use. Right. Anybody can use it. Right. Theirs are a little bit harder for your average everyday consumer to implement. So I get it, but it's like it was too hard for them. Too hard for me to get samples. So I went to company, did a ton of research, tons of research. I remember in 2020, I was just sitting down in my room, just every night, just for like 6 or 7 hours, just sitting down late into the night, researching radiative cooling, researching everything. And self-taught myself material sciences and all this crazy stuff just so I could just learn more. And then I talked to the CEO of another radiative cooling company, and he answered a bunch of questions of mine. And then I finally got a sample of this stuff from a company, and I still work with that company. I'm not going to name drop them here. I don't know if they'd like that, but I still work with this company, and we're working on like a little licensing deal right now to get their technology from them, because they don't commercialize. They don't commercialize things themselves. They're kind of more of an R&D company.
Right, like an OEM, right?
Yeah, sort of. Yeah, pretty much. Yeah. So, but I mean, this was a lot of time, a lot of labor, a lot of mistakes. I still have failed prototypes sitting around somewhere. I mean, if you look at my keyboard, there's like little flakes of this stuff from the early prototype underneath the keys, because it flakes off. The original one's flaked off.
Okay.
Like imagine just like really thick paint that's dried and just flakes. So this new one doesn't do any of that. It's super flexible, super stretchable. It took a long time to do it. I had to meet a lot of interesting people to get that right.
That was actually the thing that I wanted to dive right into, because I mean, I have to say these type of materials is incredibly cool. So jumping right into the science behind all of this, right behind the whole radiative cooling tech that you currently have. Could you please explain to anybody out there who might be listening, who might not be familiar with radiative cooling, the principles of how this works? How does it actively cool something that is right under the sun?
Yeah, so it's really cool, literally, how it works. So basically, there are two main effects going on here. One of them we're all familiar with, reflection, right? I got a mirror about 45 degrees here. There's a mirror. Things reflect, right? We all understand that, right? We've all seen mirrors. We all kind of get that idea. So that was pretty easy for people to understand. So it's highly reflective. That's why it's white, right? Because the white is just it's like a byproduct of it being highly reflective across multiple energy spectrums, right?
Right.
But then there's a second factor that most people aren't familiar with because they can't see it, hear it, or touch it. They can kind of touch it, but they can't really recognize what it is. And that's called emissivity. And emissivity is essentially, dumbed down, like a material's ability to either gain or let go of energy, right? In the same way that water rolls downhill, right, and gas goes from a high pressure state to a low pressure state, energy will tend to go from a high energy place concentration to a low energy concentration, or hot to cold in this instance.
Right.
But sometimes there are things in the way that make it difficult to do that. On Earth, we got the greenhouse effect, which keeps us nice and comfy so we don't die because of the vacuum of space, because it's really freaking cold. But the greenhouse effect is not absolute. It's not absolute. There are certain very small spectrum, very small part of the atmosphere, the electromagnetic spectrum that has not a literal hole, but a spectrum hole in it, right? So it's in the 8 to 13 micrometer range, pretty much. So imagine, you know, a little dip. If you got a chart full of the spectrum, there's little dips in it.
Right.
And if you can tune the energy to that, you can actually bypass our greenhouse effect on this planet because we don't have the gases present to reflect those specific wavelengths.
Right.
So what this does is it basically converts any energy that it absorbs into that wavelength and allows it, with a clear view of the sky, to shoot it off into space. So between the reflectivity and the emissivity, you can actually get a pretty high daytime differential, a delta, between like another very white reflective material and this one. So if you had like a 95, 96, 97% reflective material, this will still beat it out. Why?
Wow.
Because those things aren't emissive. They're not as emissive. There's partial emissivity, but it's not like designed emissivity. I've gotten up to 30 degrees temperature difference before. 32, actually. I have a picture of it.
Wow.
Which is kind of incredible. It's really related to a few factors. So what many people ask, what affects it, right? So it's things like humidity, how dirty it is, right? If it's cloudy or the things above it, what's the base temperature outside, right? If it's hotter, it actually works better. Wind speed. There's a lot of different atmospheric conditions that will affect it. But that's why I work with averages. That's why I say 15 degrees, just because that's an average I've landed at. I've gotten 30, I've gotten 7, right? I've gotten all sorts of things. But 15 seems to be like, if I had to just close my eyes and throw a dart at a board.
Right
about in the middle.
Right, it's a perfect average. So thank you very much for sharing that. I want to actually ask you pretty much about these. You know, you already mentioned that the way it works is through these very specific wavelength, right? Is that the reason why you mentioned that this device has to be exclusively color white? Because I mean, in the end, color is a form of wavelength, right? And white is the combination of the lack of this all. So how far along into your own did you actually discover that these could only be white? Did you try different colors? Did it work?
Well, okay. So the emissivity and the reflectivity, like I said, they're two different factors. So the being white is a result of it being reflective.
All right.
Emissivity, you can have highly emissive objects that are black.
Okay.
Right? Really black, right? But the problem is that when you put them outside, emissivity is a two-way street. Right? When you put it outside, you're maybe going to get 7 degrees of cooling emissivity, but you're going to get 50 degrees of heating.
Right.
From the direct transfer of the sun. So if it's not reflective, then you're absorbing way more than you're emitting, right? Which is a problem, right? So the reason I keep it white is because I want to get that full effect. This is not about aesthetics really, although it is quite aesthetic. It is about performance, right? Because at the end of the day, this is going to go on top of roofs. This is going to go on top of boxes that no one looks at for 5 months, right? This is going to go on like niche IoT products, right? Where they care about one thing and one thing only, and does it cool the inside of whatever I'm putting it on, right? And if
Right.
it can't do that, even if it looks fuchsia pink and it looks great, like who cares, right? Although now let me backtrack a little bit because I started in the consumer market. One of my main issues is that people would ask, does it come in any other colors? And I kind of figured out a way. That's what the cryo tile is.
Right.
I'm still working on it. I do want to make that. I'm still working on that, the cryo tile. So when it says coming soon, it means eventually. But I do have a prototype sitting on my desk actually. But
Oh, nice.
yeah. I'm not going to show you guys though.
Oh, come on.
It's not pretty. It's not pretty. But I do have a, let's see, I got a manufacturing mold for it. It's like a little.
Oh, that's cool.
Yeah. This is like stainless steel. But so what I did is I was like, okay, I can't make the material itself any other color. But what I can do is I can make the border a different color.
Right.
Usually that's enough for people to be like, oh, I like this one over that one, right? It actually makes a difference for them. There's one other thing I wanted to try to change the color, but it's a theory and it involves like pigmentations and micropigmentations. But again, I don't think anyone's done research on that yet. So I would have to find someone who knows more about that than I do and have them do it material. Because you can print on this. You can actually print on the vinyl.
On the vinyl, yeah.
Yeah, it's like paper. You can write on it. I sometimes use it when I'm shipping out products. I even write on it. It's like a shipping label. So it's super great for that. So I think it would respond well to certain ink colors. And if I do enough of them, I can maybe make it like a hue of something. But anyways, that's down the line. Right now, just performance.
Yes, and I mean that is something that I wanted to ask you precisely. The part of performance, which is, in my opinion, the most important aspect of any new device that you're launching, right? Especially when you're talking about consumer tech, and not necessarily just consumer tech necessarily, but also, for example, your work with Extronics, precisely, right? They build these drone nests, and I can only assume this is something that I want to ask you, but I can only assume that you apply your your tech into these nests, especially to keep them cool, maybe, or some part of it, right?
Yeah.
We're gonna get into that in a minute, right? What kind of tests did you originally start working on to figure out the path you had to take into developing a fully working product skin?
Well, from the beginning, performance was never actually the real issue. It's always been durability and usability, right? Because you can make a radiative cooling material. It's not hard. You take titanium dioxide, you mix it up, and that's somewhat radiative cooling, right? It's not hard to do. The problem is that titanium dioxide, is it going to stick to whatever you're putting it on? Is it going to stay? And is it going to smudge? Is it going to get dirty? If you leave it outside for a week, is it still going to work? Right? And it's like, can you do it at scale? Can you do it cheaply? There's a whole bunch of questions around, and I'm not even using the titanium dioxide version, by the way. I'm using a completely different version.
Wow.
Yeah, so there's a lot of different ways to achieve radiative cooling. I mean, you can put water out on like a sheet, and that is technically radiative cooling through evaporation. But the problem is that requires water. So it's like, what is the easiest, mess-free, not going to break on you, not going to disintegrate in your hand version of this you can make? And I have to say, this is it. Like this checks all the boxes. Like, this stuff is shelf stable. I can leave this stuff just sitting for years probably, and it'll be fine. And the vinyl is self-adhering, right? It's great. So I don't have to mess with, you ever see a car wrap put on, they have to put water and stuff.
And they have to apply it with a heat gun and...
Yeah. What's actually cool is that you don't have to apply this with a heat gun, but my newest version, Cryoskin 2.0, which is out now, you actually can. I adjusted its formulation to make it more flexible and actually respond better to a heat gun. So that way, automotive installers, when they're applying this, they can actually stay with the same workflow that they normally do. They don't have to adjust anything. Which means that a beginner automotive guy could pick this up and be fine, and an expert can pick it up and be fine.
Right, true. And actually, I wanted precisely to talk about these more sort of industrial use cases that you have for the device, right? Because, I mean, let's face it, the cryo tile is very, very cool. I mean, the Cryo skin is very, very cool. The Cryo tile also. I mean, I've already seen it on the website. In fact, I just opened the website recently because I wanted to see it. The little music greeted me. It's it's pretty nice in the website. But these industrial use cases, right? How did how scalable was it at the beginning to actually develop a very DIY vinyl, like in this case, right? I mean, because I mean, I can only imagine that the first iterations or the first prototypes required some very specific conditions to work properly. Now, in your website, everything you actually mention is you need to have a clear view of the sky. It has to be. It doesn't need to be perpendicular to the sky, otherwise, it's going to have an inverse effect, right?
Yeah.
How did you translate all this from the very first steps or the very first iterations or prototypes into the current use cases that you have that are for cars, that are for these nests, not just the cell phone or laptop, which are very small devices, but these huge, very, very somewhat complicated tech like cars and stuff.
Yeah, so that's actually like easier than you think to translate it from consumer, from B2C to B2B.
Right.
Because when you start with a B2C base, you have to be so much more diligent about everything your product does. So for instance, like if you ship a product to B2B, they don't care about half the stuff consumers care about, right? They care about, like, imagine a Venn diagram. Like the Venn diagram is like almost completely overlapped, except for the consumers want way more. So consumers are like, well, just come in other colors, right? So that's where it starts. But also, do I need tools to apply it? And if I had to make a special tool to apply my vinyl, I wouldn't be able to sell any of it because I'd have to make a tool and sell the tool and just be too much. Instead, you can just use household scissors. I mean, you can just use household scissors to cut it. You can use a razor blade. It's just like a normal vinyl. You can put it through a vinyl cutter at your house, make your own foam skin, right?
Yeah.
It's super easy. There's other features too. Like the vinyl I use it's pressure sensitive, meaning you can make mistakes. You can just take it off and then reapply it if you mess up. The one that I have on the back of my phone here, I have taken off and reapplied almost like 60 times. Like just because people ask, I take it off, I hand it to them, they pass it around, and I put it back on. I've done that like 60 times and the vinyl is still fine. Everything's still fine, right? So it's durable. Durability is important. Like with a B2B customer, I don't know. Are you in Phoenix?
No, we're actually in Mexico over here, which is equally just as hot, I have to say.
Yeah. So in Phoenix, they had an issue right now. Like half the lights across the city are purple, like the street lights out at night. They're purple, and someone might fact check me on this, but my brother, I asked him and he looked it up and he told me that it's because like a lamination layer on the lights on like all of the street lights broke. So that's supposed to filter them. So instead of them being orange, they're now purple. So everyone in Phoenix knows exactly what I'm talking about. There's like, you just drive down like any of the roads, there's just like purple lights everywhere.
I actually just searched it. It seems to be something regarding that lamination that gives it a sort of a white color. I mean, it degrades. Oh, yeah, interesting.
So the B2B guys can make that mistake, right? They can do that. But if you shipped any of that to a consumer, there'd be like a class action lawsuit.
Wow.
Right? Yeah, right. Think about that. Imagine if you were supposed to ship like ceiling lights and they turn blue after like 2 months.
Right.
It's class action. It's mass return. You're done. Your business is done. But I'm fairly certain the business that shipped those lights is still going to be replacing them and making money on that. Don't know for certain, but I suspect it.
Right, but it's because of the way that these B2B versus B2C landscape works. Like I understand that.
Yeah. So again, consumers, so much more difficult to deal with. So their baseline of bullshit is this high. B2B is just this high. So the adaptations you have to make to fit B2B is not much, especially when you start here. Yeah.
Got it. That's actually a very, very interesting thing to know. I didn't really expect that to be the case. But now I wanted to jump into a whole different aspect of this, right? Which is once you already scale up your devices, you start thinking about more, larger orders, for example. Maybe you were asked for a ridiculously large vinyl, right? Which can happen. How were these first experiments on manufacturing this on a large scale?
So right now, I'm actually still trying to manufacture this on a large scale. So far, all my manufacturing is done basically out of my apartment.
Wow.
And Yeah, I have a dude that I know who makes the vinyl. He takes and laminates vinyl. I know I have a dude who does the paint, right?
Right.
Those two dudes are basically my branches of my supply chain here. But it's not because it's difficult to bring manufacturing in here, it's just because it's expensive, right? So right now I'm actually raising money to bring this process in-house in Arizona, all under one roof, and streamline
Mhm.
it. So because at this point I can barely meet the demand of my existing customers, including Hextronics, right?
Right.
They've had to wait on orders from me just because I had to take the time to go make it. It takes like oh geez, like an hour per 10 square feet, right? And they're requesting
All
20
right.
for 60 square feet, right, at a time. And I got other people who are requesting, and I got other
Yeah, of
people,
course.
right? It's
Definitely
just
not
too much.
scalable yet. I understand.
Not scalable right now. However, to make it scalable is not that hard. It's actually not even that expensive. It's just I'm a startup, so it's like I have to
Yeah,
get,
yeah. It's
$1,000 here, $1,000 there.
one step at a
Purchase.
time.
I know, yeah. So I'm working towards it. In fact, yesterday I was touring some commercial real estate to try and find a spot where I could put a laminator in there and just
Wow.
start away. Because I already have all the vinyl and I already have half the paint. So I
Right.
just need to have the process to do that.
Now that you actually mentioned this real estate, I wanted to ask you something. It's not necessarily regarding finding this place, but applying your Cryo Vinyl,
Mhm.
right? Now, I saw on one of your LinkedIn posts recently, this was a couple months ago, that in a single day you received like, I believe it was like 10 different requests for 10 different use cases of the Cryo Tile. Some of them were cars, some of them were like golf carts, I believe it was.
Yeah, for the cryo skin. Yeah.
It was a very 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 particular thing. One of which was a mobile home, right?
Mhm.
Um, so my question to this is this scalable enough actually to go and jump into perhaps houses like buildings? Is it something possible? For example, think of it as solar panel arrays, right? That are on the top that are facing. This sounds like this can be applied somewhat easily to houses. So is that something that has already been done? On how does that look?
So there's a few different factors in that ideally, yes, I'd like to hop into that market. There's a few different
Hmm.
factors to pull the trigger and say, yes, absolutely, I can do that. Um, Primarily one is cost, right?
Right.
You can get white roofing material for like $1 per square foot. Very cheap. My
Mm.
material, I have to sell this for almost $40 a square foot, right?
Okay.
So this huge differential,
Yes,
right? But
yes.
Mine can do all sorts of crazy things that the white roof can't do, right? It can do all sorts of crazy stuff.
I agree.
Specifically because this is not an insulator, right? Which
Yes.
makes it perfect for electronics and perfect for vehicles. Because if you put an insulator on electronics, what it does is that it keeps the heat that the electronics are making from escaping.
Right.
Which
So it's
basically, yeah,
it's an
it's
oven.
green. It's an oven. It's a greenhouse effect on itself, right? It's downward spiral. You don't want it. So mine, it reflects the heat away and it lets go of the heat. So that it's perfect for electronics, perfect for vehicles as well, because you get that
Mm.
active effect, cools down the inside if it's already hot and setting out, right? So with buildings, I can achieve those effects, right? There was a study done where they said you could decrease air conditioning costs by 50%, right?
Right. That
Uh,
was
yeah, but it's like, okay, you can do that, but at what cost? I
I
think
see.
with more time, more R&D, and especially bringing all the manufacturing in-house,
Right.
I could bring my cost down, so I could bring the price down. I think I could do it. I will be able to at least cut my manufacturing costs in half simply by bringing a laminator in-house.
Wow.
That's a huge process. Yeah. So that's just something I'm like working on. So
Hmm.
for buildings, yes, and there's a lot of benefits to it. There's a study done by ASU where they specifically looked at mobile home related deaths in Phoenix alone.
Mm.
And those deaths are not only common, but they're increasingly on the rise, which is a scary thought
It's
that
alarming.
people.
Yeah.
I used to live next to a bunch of mobile homes, right? I used to live out in Mesa next to a ton of mobile homes.
Hmm.
It's scary to think that there's people dying in there. And the people in them aren't, it's like seniors and stuff. Like it's very sad. And to think that maybe if I get it low enough cost that I could help these people, right? That would be amazing.
Yeah, I agree with you that it's actually I mean, it does seem amazing that the potential of this device, or well, rather this material, it's not just on, hey, let's make the phone be a little less hot, right? Because I mean, for example, the latest iPhone 15s already been reported they're hot, but that is just very much subjective in a sense, right? That it's like, hey, I want to have this phone, but I just kind of, gets hot, too bad, but I
Yeah.
want it. It's very, very different when it comes to these applications, for example, for, well, as you mentioned, for these mobile houses, etc. Now, my question is precisely with these mobile houses. Some of them are going to be for travelers, right? Rather for people who only live there.
Mm.
How effective is a cryoskin if you go actually to a cold environment? Is it
Doesn't do
recommended? Oh,
doesn't do anything. Yeah, radiative cooling, it has like a curve where basically like the hotter it gets, the better it works, and the
hmm
colder it gets, the worse it works. It will
mm,
still radiatively cool at cold temperatures, just not as much,
got
right?
it.
A lot of radiative cooling works along a pretty variable spectrum. Like for instance, humidity negatively affects its performance. But I went down to Miami, I went down to South Beach and laid out on the beach with the cryoskin on my phone for the whole day, and my phone didn't overheat, right? So it
Right,
still works. It still works. It's just not as effective in like high humidity environments, right? Because these are
right.
all just it really depends on your localized immediate weather. Exactly what is happening above you right at that moment will
hmm
greatly impact how it performs. If you got a cloud over you, it's going to stop working. The cloud moves, it's going to start working, right?
Right.
So it's, I mean, that's kind of extreme, but like that's the general idea.
Yes, I mean,
Yeah, yeah.
oh,
Sorry.
sorry, I was just going to mention that. I mean, I totally understand that what you mentioned is that in the end, this is just a difference, right? A delta, as you is, in these temperatures and in these the emissivity, etc. I totally understand that. Now, I on your website actually you have a different application for this, right? I mean, having the besides having the phone skin and the laptop skin and the iPad and MacBook, etc., etc., etc. Besides all this, you actually sell this on a DIY type of thing, right?
Mhm.
And this is straight up from your website. Like, this is not just for orders, for example, from electronics, right? Which might be a like they are direct contact to you and they order something. It's a quotation. It's a whole B2B type of purchase. This is just add to cart, select size, straight up, right? For example, if I were to order this right now, order my own DIY skin, how long would it take for you to actually deliver this, for me to receive it? Um, Especially considering the amount of orders that you have right now. Like, isn't it turning into the point where it might be a little more like necessary to just stop consumer purchases for a moment?
Not exactly. So for the phone skins, those are kind of a pain in the butt for me to make because I have to manually final cut everything,
Right. Well,
right?
yeah, you mentioned you already have that
Yeah.
like that
Yeah,
cutout.
yeah. Yeah, but what I've done is the pricing, let's be honest here, the pricing for the DIY and the pricing for the phone skins is high, meaning my margins on those are actually very good.
Mm.
Um, so if I sell B2B, my margins have to go way down, at least for some, just because of scale, right?
Yes,
That's how
totally.
in this world, scale, discount, right? So actually this cut that was done right here, this cut is from an order I shipped out yesterday, a DIY order. They ordered a square foot of it. It was their second order, actually. They're a repeat customer. If they're watching
Nice.
this, let me know what you did with it. I have no idea. I don't know why they're getting two of these, but they obviously like the first one.
That would be really
Um,
cool.
yeah. So either way, like the margins on the DIY shipments are good. Yes, they take a little bit of my time because I have to manually pack and ship it, but
Yes.
you know, I think the opportunity for people, I mean, because yes, it could be grandma trying to put this on, a birdhouse, right? Which is cool. But it could also be like a guy with some sort of like car thing, or maybe some sort of like uh, equipment or something that needs to get cool. Maybe it's got like a specialized machine
hmm
and works for a larger company and he tries it out and it works. And then next thing you know, that turns into a large order,
Right.
right? That turns from B to C to B to B just because one of the employees can take initiative,
Right.
right? I mean, that's often how a lot of electronics in the consumer space become prevalent in larger companies, right? You have an employee who uses it on the side, like they'll have a smartphone or a tablet, like an iPad, right? That's how iPads became so ubiquitous in the
True.
education, right? Because people saw like, oh, iPads are cool. Like you can write things on them and they last all day and they're
It can be
reasonably.
my notebook, yeah.
Yeah, so then they were like, okay, well, let's try this a bit. Well, I got an iPad at home and it works great, and he's got an iPad. Well, okay, we'll just bring him into education then, right? So if people just have this, then they'll figure out how to integrate it into other things. That's part of it. It's also the margins are good. So those are the kind of two reasons there.
Right, and that's actually pretty cool. Now, I wanted to ask you, now that you already mentioned that about these repeat customers, that you asked them what they were doing with this, that you were curious about it. I'm curious about what is that you know of, at least, and that you can share about. One of the most maybe extreme or maybe curious use cases that you've seen the cryoskin applied to.
Yeah, so let's see. I can say it, but I have to be careful about what about it I say.
Right,
Because it is
understandable.
a top secret application. So I'm not going to say their name, not even going to say what it does. I'm just going to say that it has something to do with sulfuric acid. And yes, that's all I'll say. And basically it's a box and it monitors things, and there's sulfuric acid involved. And it's in a place where it's hot and sunny, and the electronics in the box need to get cool. So that's something cool I'm working on. I just shipped out one of those orders last week.
All right, that seems to be not necessarily a very typical use case, if I have to say. Especially sulfuric acid is not a very common element to, or not a very common solution to use in in tech. So it's interesting.
Yeah.
It's great to know that your that your cryoskin can adapt to so many different scenarios. Which actually leads me to one other question that you have, and you already mentioned this, right? Which is durability. You already mentioned that, well, durability is first of all one of the things that we're currently still tracking to give some more relevant results. You already mentioned that you have applied and reapplied your current skin on your phone, what, 60 times or something? Like,
Yeah.
it seems very durable. Also, vinyls, generally speaking, are quite durable, right? However, what are some of those recommendations that you have for anybody who might be using these? I know you have them on your website, but it'd be very cool if you could just share these recommendations to anybody using this. Maybe I'm a little more in the end consumer space, right? Rather than, for example, a company.
Yes. I mean, actually, I need to go through my website. It's on my list of things to do. I need to update some of those recommendations because I've been doing continuous testing on my own vehicle for months now. I haven't washed my car in like 5 months, and I would love to. It's very dirty. I would love to, but science, right? Like I'm trying to see how long. Yeah. And I'm finding out some very interesting things because like who else is going to do a durability test on my stuff other than me? So I'm doing my durability, right? I'm doing my due diligence, doing my testing. So for anyone who has like the phone skin or wants to apply it to a high touch surface, don't. Just don't. So your skin oils and the abrasion combined with it, pretty much it's not good for it. It's not good for it. It's just the oils attract dirt and you can't get the dirt off because the oils bind to the surface. It's just not good. So that's why I keep mine beneath this polycarbonate case. Still doing research to figure out how much the polycarbonate affects its performance. Safe, if you want to just be safe about it, get the most performance, don't have to worry about it, then you just take off the case whenever you want to cool it down and put it like that.
Right.
Easy, right? Like all the other times you just kind of have the case on, and it still works with the case on, but it's not as effective, right? Again, it's a spectrum of effectiveness here. So that's one thing. Or if you're gonna put it on like a door handle, just don't. It's gonna get so smudged and gross so fast, and you notice how gross it gets because it's so pristinely white. This material is so pristinely white that it's just you notice immediately any smudges, right? So I recommend instead putting it in places where you're not going to touch it, right? Things like roof of your car or on like some sort of box that you're not going to touch that's monitoring something, or like the Hextronics drone covers, right? They're not touching Those they just sit out and they do their thing. Or an HVAC unit, like put it on the top of an HVAC unit, see what that does, right? So ideally, that's where you want to put it. Another thing is like don't put any overcoats, oversprays, laminates, any of that stuff on top. It just doesn't work. I've tried a bunch of stuff. In fact, I'm doing a very definitive test with some capstone students out of ASU. Let's go Sun Devils. Doing a very definitive test on like, can you take it through a car wash? My preliminary tests say no.
Right.
But also because I took it through a lot of car washes and I was pretty tough on that original piece. So now I'm trying to determine, okay, what if you do like a brushless car wash, like a touchless, I think that's what they're called. A touchless car. Yeah, what if you do one of those? Will it be okay? Right? I don't know. I'm testing it. So these are different things that I will be updating on my website as I have this information, right? As I understand it. But basically, avoid oils, avoid abrasions, and don't put any overcoats or anything. And make sure when you're using it, clear view of the sky. The more blue it sees, the better. Blue, better, right? That's all you got to remember. Make sure it sees blue.
That's actually pretty cool. Now, I wanted to also dive into a more science-oriented question, right? You already mentioned that originally this first research was on this very specific wavelength, right? Which is something just doesn't come out of, or sorry, that the atmosphere does not reflect, right? Or doesn't diffract or anything else. Now, is there maybe a specific wavelength that you believe can be used in a lab, like in a control space, to actually make these devices or these materials have a different performance, maybe better, maybe something different, maybe for a specific range of specific range of temperatures that you wanna keep on a controlled environment? Is it something possible based on your research?
So that's a really good question. So okay. So the reason we use the 8 to 13 micrometer range is because our atmosphere physically lacks the gases that it would need to reflect that spectrum.
Right. It's a very large spectrum, actually.
It's super. The spectrum's like infinite, basically. Yeah. But like for this, like everything from way infrared to ultraviolet, we got visible, and then we got what we're dealing with, 8 to 13 micrometer. It's in there.
But it's a large wavelength, generally speaking.
Yeah, it's generally large. Yeah. So the question of like the reason why this works outside is because the vacuum of space is really dang cold, or really absent energy, we'll call it. I wouldn't say cold is the right answer, but really absent of energy. So the Earth is relatively much warmer than the rest of nothing. So it just leaves, right? It leaves through that hole because there's nothing to block it from leaving. Remember, I think like high pressure, low pressure state. Imagine you got a balloon with a little hole in it. It's slowly leaking out. That's basically all it is. It's just leaking out that little hole.
Right.
In a lab, let's see. So theoretically, because emissivity is a two-way street, right? And you can tune emissivity. This is a tuned emissivity. You can have a generalized emissivity, right? You can have different types of emissivity. The reason we typically don't use like a untuned emissivity is because it's not really effective, right? Because what it's going to do is it's going to be slightly cooler on its own than, like, let's say a wall or a tree, and then it's just going to absorb the energy from those, right?
Right.
Two-way street. That's why if you turn my radiative cooling material sideways, it gets hotter, right? That's why you only apply this to roofs. That's why you only apply it to things that are laying flat, pretty much. There can be some curve to it, but like not perpendicular.
Yes.
But there are some benefits for having it have that property, right? So here's an example. Like you could use it to cool water this way, and then water going through a pipe, right? You use the cool water going that way, and then rotate it perpendicular. Now it's heating the water, right? Very minimal energy to switch, basically a switch, right? That's something you could do. But I don't really think. I think you could use like a generalized emissivity in the lab to transfer energy between one emissive material to another, potentially. But I don't know. And again, the question would be like, what is the purpose of that?
Yes.
Like what would the benefits be? And I mean, I wouldn't know until I try it, right? So if anybody out there is doing that, I'd love to hear about that, because that's kind of mind tickling, but I don't really have any information on that.
Right. No,
Just
but
pondering.
no, but it makes sense. It absolutely makes sense, and the answer you gave is actually very very cool. So thank you very much for sharing that. Now, before continuing, before carrying on, I have to say we've already been at this call for around 45 minutes, give or take. First of all, thank you for your time. Before we approach the end over here, I just want to make sure that to anybody, any viewers out there who might be watching, if you want to leave a comment over here, feel free to do so, so that we can answer it live, or maybe we can answer it in the future once this is saved as a video on demand. We can answer it maybe on LinkedIn. So just wanted to put that out there, mention it. Now I want to go back into Jordan more. I would say more of the sort of business, sort of startup world right over here. I have to say, the Cryo X is, as you already said it, the very first. I had never even seen radiative cooling before applied anywhere. Not that you invented it, but you definitely brought it to the consumer end, right? You definitely did, and that is something amazing. It's something, as you already mentioned, not seen before. You're the only one. What kind of, if you can share this again, what kind of plans do you have for the near future, or for the long to mid-term future, if you will, to actually bring this to a far more, not just scalable, but to a far bigger outreach of people? Because I can imagine already that there are going to be some very specific places around the world where this could be a potential superstar, right? As you were mentioned, in Phoenix or in any of the places. Texas sounds like one of another very very important one. Desertic places. If you go to I don't know, the Middle East, for example, what type of scalability plans do you have to really bring this to its fullest potential?
Yes. So in terms of like the vinyl product, cryo skin, right?
Mm.
That one I'd say is like pretty much at the end of what R&D can do. Yeah,
Right.
I could do a few more interesting things. I could try throwing a phase change material in there. In fact, there's a local company I might partner with to go test something
Oh,
out with
nice.
that. Yeah, some people think we're competitors, but I think they're doing their thing, I'm doing my thing, and we happen to work in the cooling space. Um, but in terms of the vinyl, I think it's really like I've maxed out like all the features. Everything that I would ever want it to do, it does. And it does it great. The last part of it is I guess like really long-term durability. So like total abrasion resistance, total
Mm-hmm.
oil resistance. Like you can scrub it. Like I want to R&D to the point where you could scrub it with a toothbrush and it
To
wouldn't
clean it
ruin
up.
it.
Yeah.
Right? Yeah. But right now it's not at that stage. That's like the final stage. In the meantime, while I'm R&Ding that, I would preferably like to actually take the paint that I'm using and make it in a way that is consumer ready. Like just like what I did with with the
Oh,
technology itself.
nice.
I'd like to take the paint and make it consumer ready because right now it's not. It's
Okay.
incredibly toxic when it's in its paint form. When it's dried, it's totally safe. So don't worry about that. But when it's in this liquid noxious form, it's not great. And it's not, if you let it sit for more than a few hours, you have to shake it for a long time to it like separates and it melts like half the stuff I put it on. Like I have the tables I'm spraying
Hmm.
the vinyl, I've melted a few of them. Like it's quite dangerous.
Wow.
So I want to take that and be like, let's make it safe. Let's make it something you can pick
Right.
up at home, right, in the spray can or a little paint bucket, and go paint your house or something, right? That's ideally what I'd like. And to get there again, there's going to have to be a lot of R&D. So that's
Of
kind of my
course.
future for that. I mean, of course, there's other things you can do when you really get into this tech. There's like other literally cool things. Some of those revolve around answering the question that you asked earlier about like lab-based tuning stuff.
Right.
Like,
Controlled environments kind of things, right?
yeah, exactly. So right now, like there could be some really interesting applications if
Hmm.
some part of that were true. I don't know. But again, once I R&D it more, I can figure those things out.
Right. And actually, honestly, it is a very very interesting thing to expect, because I can see myself just using this as you, which I have already noticed by now, are a huge fan of technology, phones, accessories, etc. Like you already mentioned MKBHD and the brand, and all of these. Like I'm a huge fan myself of Maxim accessories and stuff.
Shout out to MKBHD. He's
Shout
actually
out.
the reason. He's actually the reason why I got into consumer electronics in the first place. When I was a kid, when I was younger, like a teenager, I'd watch his videos. And I was like, dang, this is a professional making some real good content on technology. And that allowed me to just get into it. So that was really cool.
That's very cool. And that is precisely the question that I have. Now, these, the you know, the devices that you're building, you already have, for example, the DIY and all of these sheets and everything. But also, what you already mentioned, you have the Cryo tile coming out, which is essentially a Maxim accessory for it. Like, you can literally stick it on the back of the phone here and just, it's gonna stay there, right? I have two questions for this. One of them is oriented in the, you know, in the science part. The other one is more about the reach and visibility. But on the science part, I'm curious if the magnets actually affect in any way to this, or, you know, not at all. I would assume not, right?
No, there's no magnetic effect on radiative cooling.
Right.
At least none that I know of. Although it is in the electromagnetic spectrum, but like typical magnets aren't going to be doing anything.
They're going to be very strong, right? And
yeah.
And so the other question that I have about this, well, following up in this really, is, I mean, the thickness of the vinyl. How does it affect in the actual end result of cooling down a device? Because, I mean, I can understand applying it directly into the phone, right? But for example, it would not really make sense to apply it on top of a case, for example, and then slap that case onto the phone.
Mm-hmm.
So how is this? How in contact does it have to be, or more specifically, what is the width that it has to have to make a real effect?
So basically, you're asking the question of thermal transfer, right?
Mm-hmm.
How do you get a cooling effect from one surface to another?
Definitely.
Now, with the current vinyl, Cryo 1.0 was 0.14 millimeters thick. The newest version is 0.07 millimeters thick. I cut it in half. And I did that so it would be better for my automotive class. But people ask, does the new one have better performance because there's less vinyl? Yes. The answer is not measurably. So when people think about thermal conductivity, they often think, oh, you're using plastic. Plastic isn't thermally conductive, therefore it's not going to work.
Right.
That's not the case, because they're forgetting that there's like two main factors of thermal conductivity. There's the physical conductivity of the material, and then you have the actual like surface area that you're applying it to, right? That's why you use in a computer, that's why you use thermal paste, because metal on metal, that's pretty good, but you have, like, imagine the knuckles of my finger here. You have gaps. You have gaps in between the piece of the atoms. The surface is not completely smooth. Well, when you use thermal paste, it basically fills in those gaps and allows you to have more contact, more transfer area for you to transfer energy through. So this vinyl, it's sticky. Why are things sticky? Things are sticky because there's this really close bond. Right. There's a lot of surface area, right? That's why geckos can stick on walls, because the feathers on their feet expand and create a larger surface area.
Right, it's a friction matter.
Exactly. So the surface area add of the sticky material actually like works really well for thermal conductivity if you're applying it to a surface, despite the fact that it's polymers and plastic, which are typically not viewed as thermally conductive. So now we take that question and we go to actually no, sorry, I think that answered your question. Right?
Yeah, that definitely does answer the question about, you know, these pretty much the thermal conductivity and about the width of it. It's amazing how thin you actually managed to bring it, right?
Oh, now, actually, that's not the hard part. The hard part was making it thick. That was the hard part.
Really?
I've actually intentionally made it. I'm trying to keep it from going to like 0.3 and 0.2.
Okay.
If it's too stretchable, then it'll break the paint, right?
Oh, right.
I've engineered the paint to be really, really flexible. Like, it can flex a few inches, which is incredible. Because the original one, you could look at it funny and it would crack. But this one, you can really stretch it. But there's like a point, right? There's
of course.
Elasticity.
A critical point.
Yeah, it's a critical point. It's like shoot, I'm blanking on it. But basically it's like a deformation thing where it's like you take it to a point, and once you take
Past
it to
that,
that
yeah.
point, it won't go back. Right.
Right.
So with this one, it's got a pretty good amount of that.
Hmm.
And the paint can actually do it. But if I get it any thinner, it'll stretch too much, and I can't work with that.
Right,
Nobody
right.
can work.
It's sort of like a rubber band. If you expand it to a certain point, it's just
Yeah.
not gonna go back to its original form. I completely
Yeah.
understand that. That's actually very interesting. Thank you for answering that. Now I just have one final question, one of two final questions that which is one just because I'm also a huge fan of watching videos about tech and stuff and accessories and everything. Do you believe we can expect to see the cryo tile, reviewed over these hundreds of YouTube channels across the world as an accessory for cooling down an iPhone or a phone?
I really hope so. I mean, again, right now my focus is not on the cryo tile simply
Right.
because I'm just trying to meet demand for, industrial products. But that does not mean I've forgotten about the cryo tile, and that does not mean I don't have a patent on it. So I
Nice.
um it's something near and dear to me. I spent a long time prototyping it, so like it's one of my babies, it's
That's
one of my
very cool.
kids. Neglected right now, but I love them nonetheless. Yeah, so the cryo tile is really not taking a lot of precedence right now, but the fundamentals are still there.
Hmm.
And I think if I once I have enough time, or if I had like a team, right, I could
Right.
deploy a team to go do it because I've already done most of the legwork. They just need to figure out who's going to make it. And there's like one like small issue that just needs to get resolved, but it's just like a material sourcing issue. So
Right.
other than that, it's pretty much ready to go. And the crowd tile, it would be pretty awesome the way I've designed it, right? It's simple, easy to use, just magnetic accessory. It's really durable. I bypassed the smudging issue by just
Hmm.
encasing it with polycarbonate. I do a bunch of things to it to make it really durable and aesthetically pleasing. The color palette I chose.
It is very
Uh,
nice. I do agree that well, it's like the cocktail themed colors. It's really nice. They're really nice.
yes,
They're actually
yes,
pretty cool.
yes. Yeah, I
Now,
do have a brand, right?
yeah, yeah. I mean, they're actually very nice. And now, just trying to get into the end section here, but just questions keep coming and coming. I mean, what do you want me to do?
Bring them.
Um, do do you have a plan, for example, to actually go and maybe put yourself in front of these very huge like VC investors, sorry, or for example like a Shark Tank type of deal to really scale up Cryo X? Is this in your plans, or with the current funding you have right now, which I understand that you already have some backers? Is that enough for the time being, or because of these demand sort of pressure that you currently have? Do you have these plans in the near future to actually go and do an investment round?
Yes, I'm absolutely going to go raise some money. Just because I see the scale, right? I only have like three customers, right?
Mm-hmm.
And the amount of demand those three customers are bringing is insane. I'm far behind.
Right.
So I need to catch up to that. And then while I'm at it, I'm also kind of looking for other customers. But the reality is, if I get another customer and they ask for anything, it could even be
Right.
20 feet, I'm going to be back ordered immediately. Just because everybody wants it and I can't make enough. So priority number one for CryoX right now is acquire the manufacturing space and the equipment necessary to produce enough of this to meet my existing demand. That's priority number one. So I
Mm,
will be going to all sorts of pitch competitions.
that's cool.
I'm gonna be in New York and Philadelphia and San Francisco and all sorts of places in the coming months.
Hmm.
So I mean, hopefully, if there's somebody out there, if they're interested, I'd be happy to go. Sit down for lunch or coffee or whatever.
That would be really
Um,
cool.
or if you're in Arizona, come say hi. I'm here. So
Well, I'm glad to know that this is already on the plans, it's already on the works, and I mean, I ask it because I really honestly see this as a very disruptive uh, end consumer technology, right? Especially for the consumer tech industry, like phones and AirPods and everything. It's a very hot right now. For example, as I already mentioned, just recently the new iPhone came out, and with it, a whole wave of new accessories, right? So it's definitely a growing market. So I'm really glad and I'm really happy to see that you're scaling this up. I'm very happy for that. I already crossed the 1 hour mark that I mentioned I wanted to stay in. I'm sorry for that.
Oh, you're good.
I just want to delve into the last question over here so we can give this a proper closure because I believe it's been a great conversation and very
I agree.
insightful. We've learned about cooling tech. We've learned about emissivity, but we've also learned about the manufacturing challenges of a startup one man job, right? My
Mhm.
question to you is, especially with your history that you started this during college, like a project, what advice would you give yourself when you were just getting started, like the path that you've already come along so far? What advice would you give yourself when you were just getting started with this idea?
Ooh, well, I got a lot of advice. One of them would be like, don't be afraid to sell, right? A lot of times in the beginning, there were people interested, but I didn't sell them because it wasn't ready. But I think, many people will buy before it's ready. I mean, again, you get back orders when you do that, but
Mm,
that's kind of just how things are when you're a small startup making a unique product all by
right.
yourself. Like if you want it, you're gonna have to wait, right? Although right now, I actually am not totally behind, so which is great. So if anybody out there is actually interested in ordering, I do have some in stock.
That's
So just
nice.
yeah, but and it's actually CryoSkin 2.0 as well, so it's the good stuff. Uh, Although original CryoSkin is just it's pretty good. It just depends what your application is.
Right.
And then another thing would be um, just get out there more, right? I think one thing I realized recently that I wish I had known a little bit earlier is just like you can actually tap a network locally very quickly. Like you can spend 10% of your energy getting 90% of the people you need to ever meet, right?
Mhm.
And then the rest will either just come to you naturally, so it requires very little energy for that last 10%, or you'll try to go and find them and you'll
Right.
spend 90% of your energy trying to get that last 10%. But if you go outside of your usual networks, whether that be like a local network or a state network or the valley or the city or whatever,
Right.
in places that you don't normally hang out or you never go to or cities you've never been, you find that network expands quite quickly without you having to do very much. So I would have definitely said like Jordan, go travel, like like which I did. That's how I got really my first big success and start. I met my first investor, my first large investor, and I met my first large client at the same convention in the same room at the exact same time. They were talking to each other. They didn't know each other yet, and I didn't know either.
Wow.
Just bumped into it from one convention in Miami, right? The same Miami convention where I laid out on the beach and tried it out.
Right.
The same place. So,
That's wow.
so that's what traveling does for you. So that's what I'm going to be traveling a whole bunch for over the winter, especially because sales typically slow down over the winter, right? It's a cooling product, you see how it is. But I'm going to be traveling a whole bunch, right? Just
Right.
expand.
Right, and I mean, I definitely agree that this networking, which is essentially what you're referring to, is critical for any startup. So, thank you very much for that advice. Because I mean, typically in this side, I ask, what advice would you give a different, like a young entrepreneur or whatever, right? That's typically what I ask, but that's you. So,
Yeah,
so yeah,
that's me.
that's definitely why I wanted to ask what advice would you give yourself. Hopefully, help somebody out there while starting their own path, maybe at sort of at the same scenario that you did, to already have a little bit of a head start, right? Which is before I let you go. Actually, we have a comment from Ray Ellich. We should have a
Oh,
couple of
Ray.
questions.
Whoa. Hi,
Oh,
Ray.
well, seems like you already know each other. Thank you very
Yeah.
much for that. He left two questions over here on the chat right now. First of all, how many parts complete the product, Cryo Skin?
How many parts?
How many parts complete the product? Now, you already mentioned that it's essentially, the vinyl and the paint, right? It's
Yeah,
virtually two.
that's it.
Um, right. Now, he mentioned also, what is the highest cost of any individual part?
Oh, the paint right now is the highest cost part. Right now, until I get my licensing deal done and all that stuff, which
Mhm.
it's in the works right now. It's great.
That's great.
But until I get it done, I have to continue purchasing the paint from that original supplier, that OEM. And at the current price point they sell it, it is actually the eighth most valuable liquid in the world, right after
Wow.
human blood. Right after human blood. Um, yeah,
Wow.
at least on that top 10 list I Googled, but it's quite expensive. So
The fact that it
uh,
appears already is It's quite high, yeah.
It's quite expensive. So simply by bringing that in-house, I can greatly reduce costs. It'd be insane. I could really reduce some costs.
Wow, I did not expect that answer, but hey, Reid, thank you very much for leaving that question.
Thank you very
Yeah, yeah, appreciate it, and I believe that is a great way to already put an end into this conversation. It's been a really great, somewhat long podcast, but hey, that's the point of this, right? To just
much.
have real nice conversations. Thank you very much for that. Before I let you go, I just want to make sure that we all know where to find you because this is an amazing thing. Actually, Ray is asking to display the product. If you want to show it one last time, it's a very cool looking piece of white sheet.
Wow, look. There it is.
There we go. Where can we find you? Where can we find Cryo X? What are your social media handles?
Yeah, so I need to get back on social media. I don't really like social media too much, but you know, you got to do it. So I am
You gotta
on
do it.
all the socials for Cryo X are at Cryo X Co, CRYOXCO. My website is cryox.co. My name
Yep.
is Jordan Fourcher. You can find me on LinkedIn. Its last name is Fourcher. You can follow me on Instagram, I guess. Again, Cryo X Co Instagram. I also have an Instagram. You just look me up. I show up. So yeah.
That is amazing. I really do recommend looking at your website, and I believe it was the Instagram. It has some really cool showcases of the crowd tally. It's actually amazing. And on your LinkedIn as well, I would highly recommend it. I already left, by the way, the website on our chat, so you can just click it and go straight into it. It's honestly a very, very cool thing. And with that, I believe it is the perfect, again, ending for this interview. Remember that you can find more information, very interesting articles, and a lot more interviews directly on our website, buildernation.io, and as Builder Nation across all the social media. We're going to also hear from you. Thanks again for being part of this community. Jordan, thank you very much for joining us for this episode. It's been a pleasure. We were so lucky to have you. Thank you.
Thank you.
And goodbye, guys. Thank you very much.
When building the future is your priority, tedious procurement processes should be last on your list. The problem is that purchasing data is scattered across spreadsheets, receipts, emails, and messages. Tracking it all sucks and makes it easy to commit mistakes. Introducing the Control Hub Way, the all-in-one purchasing software for hardware companies. Buying parts, services, or office supplies? Submit a quick purchase request to buy from your list of approved vendors, or buy from a new provider. Buying from approved vendors is even easier. Import your shopping cart directly into your purchase request using our checkout integrations. When the order is ready, submit it for approval. We'll ping all pre-designated approvers both via Control Hub's website, email, and Slack notifications for a faster turnaround. If you need a PO, we got you. Generate it in one click. Online purchase? Boom, virtual card. Do an automatic 3-way match, pay invoices, and sync everything live with QuickBooks or NetSuite. Purchasing just got a lot easier. Control Hub. Get back to building.